I've got only 3 minutes and 14 seconds to explain the concept of the indefinite integral. Let's take a simple function. For example, f of x equals x squared. Its derivative is 2x. So far, so good. But now let's try the reverse. Is there a function whose derivative is exactly x squared? If you think about it for a moment, you'll realize that x cubed divided by 3 works. Its derivative is indeed x squared. But that's not the only one. X cubed over 3 plus 1 also works, and so does x cubed over 3 minus 10. In general, any function of the form x cubed over 3 plus c, where c is a constant, has x squared as its derivative. All of these are called antiderivatives of f of x. We've just described the concept of the indefinite integral, that is, the set of all functions whose derivative is the integrand, or in other words, the set of all antiderivatives of the function f of x. Here's a table showing some of the most common indefinite integrals. Hey, don't know what a derivative is? I explain it in exactly 3 minutes and 14 seconds. Just click the link in the description. As you can see, integration is sort of the reverse operation of differentiation. And in fact, some of the rules that apply to derivatives also apply to integrals. For example, the integral of a sum is the sum of the integrals. The integral of a constant times a function is equal to the constant times the integral. These are called the linearity properties of integrals. They're simple but fundamental for more advanced calculations. All right, but how do we actually compute these integrals? There are several methods, each useful in different situations. The first one is integration by parts. It's useful when we want to integrate the product of two functions. Basically, it helps us turn a difficult integral into one that's, hopefully, easier to solve. Another widely used method is substitution. It works when the integrand contains a function and also its derivative or something close to it. We make a substitution, change the variable, and the integral becomes easier to handle. To wrap things up, here's a practical example where we put all these techniques together. So, did I manage to explain the integral in 3 minutes and 14 seconds? If it's clearer now, mission accomplished. Don't forget to subscribe. Let me know in the comments what you think, and see you next time.